Alright, so notice the title of this one is called Solving Quadratics by Factoring when A is bigger than 1. So 5.5, we did factoring when A is equal to 1. So when A is equal to 1, it kind of looks like that first problem I had up here on the board. Our A term right here in the front is 1. And when we do that, we can kind of get the answer pretty quick. We just find two numbers that multiply to be C and add to be B. Today we're going to look at when our A is bigger than 1. So it might have 3x squared in the front. It might look something like that. So when our first number is not 1, if it is bigger than 1, here's what we're going to have to do. So step 1, it says make sure quadratic is set equal to 0. If we look at number 1, it's set equal to 0. Check. Number 2, factor out of GCF. So what does GCF stand for?
Greatest common factor.
Greatest common factor. So if it is possible at all, we want to get our A term. So here it's 2. We want to get that to be 1. And then we can do like the method we learned the other day. It's a lot quicker and simpler. So when you factor something out, you're pretty much just dividing everything by that number. So if you look at all of our coefficients here, we've got positive 2, negative 6, and negative 8. Is negative 6 and negative 8, can you divide those by 2 and get a whole number? Yes, 2 will go into both of those. So the way it's going to look is you're just going to have a 2 on the outside, have open parentheses, and then you're just going to divide each coefficient by 2. So the first one, you're going to have x squared, 2 divided by 2, then negative 6 divided by 2 will be 3x, and then negative 8 divided by 2 be minus 4. So now that we've got our 2 on the outside, he's just going to hang out there. We're not going to do anything else with him. We're not going to distribute it back in because that'd be like the opposite of what we just did. We would have just wasted our time. So now we've got our A equal to 1. That multiply to be negative 4. And add to be negative 3. So who can tell me what two numbers that would be? Multiplies to be negative 4. So we know one of our numbers is going to be positive and the other one's going to be negative. Yep, 1 and 1 times what? One times what is negative 4? Negative 4. So 1 times negative 4 is negative 4, and 1 plus negative 4 is negative 3. So that's going to be our two factors. So just like we did the other day, all we do with them is put them in parentheses with our x's. So we'll have x plus 1 and then x minus 4 because our 4 was negative. And who can tell me what we do next? Who remembers what we do next? Switch the signs. you can do it that way. That's pretty much the shortcut to what we're doing. But we're not going to do that because here in a second that's not going to work that simple. What you do is you break them apart. X plus 1 equals 0. And then x minus 4 equals 0. So break them apart, set them both equal to 0, and then solve for x. So on this side, we're just subtracting 1s. X equals negative 1. On the other side, we're adding 4. We get x equals 4. Alright, what about number 2? First step, make sure it's set equal to 0. Check. Factor out a GCF. Our A term is 3. So can we factor, does 3 go into 6 and 45? It does. Perfect. So we're just going to divide each one by 3. Negative 6 divided by 3. Get a minus 2x there. And what about 45 divided by 3? Yep, minus 15. So now we need two numbers. Multiply to be negative 15. Add to be negative 2. Some numbers that multiply to be 15. 5 and 3. I think those will work. What's our signs going to be? If they need to add to be a negative 2. Is 5 going to be positive or negative? Negative, yep. So we'll have negative 5 times 3. Negative 5 plus 3. Works out. So now we set them up in our parentheses, x minus 5 and x plus 3. Now we just split them up, set them equal to 0. Solve for x and we get x equals 5 on this side. And x equals negative 3 on the other side. Alright. Are you all good with 1 and 2? They're about to throw a curveball at us. So if we look at number 3, our first step, make sure it's set equal to 0. Check. Step 2, factor out a GCF. Our A term is 2. So let's see, does 7 and 6. Can you divide both of those by 2? Not 7. You can divide 6 by 2, but we have to have all of them be able to do it. So what we just did on 1 and 2 isn't going to work. So here's where things get interesting. We've got this box here, quartered up into 4 smaller boxes. Your A term, 2x squared, it is always going to go in this top left box. 2x squared. Your C term is going to go in the bottom right box. Then we need to multiply our A and our C. So that's 2 times 6. 2 times 6 is 12. So just like in the last two, we found two numbers that multiplied to be our C and added to be our B. This time, we're finding two terms that multiply to be 12, which we got from multiplying our A and our C. And then still, they add to be our B term, which is 7. So, what's some numbers that multiply to be 12? 4 and 3. 4 and 3 also had to be 7. What a surprise. So those two numbers are going to be our factors. And we're going to put them in our remaining two boxes. And when we put those last two in the boxes, we always are going to put an X with them.
Yeah.
So now we've got our box set up. What we do now is we're going to go across each row and across or down each column and take out the greatest common factor that we can. So if we're looking in this top row, we've got a 2x squared and a 4x. What is the greatest common factor of those two? 2. And then we've got an x squared here and 1x here. So what does that mean? If we're pulling everything we can out, that means we can pull out 1x. So let's move to the bottom row. We've got a 3x and a positive 6. What's our greatest common factor there? Three x and 6. Anybody got a wild guess? Hey, there we go. So 3 is the greatest common factor of 3x and 6. Do y'all understand why 3 is? Pretty much we're trying to find the biggest thing that can go into both of these numbers. So 3 divided by 3 would be 1. 6 divided by 3 would be 2. So 3 goes into both of those things evenly. Alright, now let's go down our columns. We've got 2x squared and 3x. What's our greatest common factor there?
Why do you get to pull an X out of the top and not the bottom?
Great question. So here, up top, where we pulled the X out, when you go across, both things have at least one X. Down here, your 3 has an X, but your 6 doesn't. Does that make sense? So there's no X with your 6 to take out. But on this one, when we go down, we've got 2x squared and 3x. So we can pull at least one X out there, right? And then the greatest common factor of 2 and 3, that's just going to be 1. Alright, our second column here, 4x and 6. What would that greatest common factor be? 2. Good. So now we're going to take what we've got on top here and on the side, and that's what's going to be what goes in our two sets of parentheses. So we've got 1x plus 2. I'm just going to put x. And then what we've got on the side here, 2x plus 3.
I'm going to stop you right there. Will you show them in the calculator how they can type that into the y equals and check their answer?
Yeah. So, if you all come, if you have your calculator and get on it, in your y equals up here in the top left hand corner, if you type in the original function up here, so 2x squared plus 7x plus 6.
You need to turn off your plot 3. And then go ahead and type in the factors into y2. Oh, and plot 1 has to be turned off too. They all have to be turned off. There you go. And then go ahead and type your factors. They'll need to be on the same line in parentheses. And then, I guess this is when you're out. Then if you hit graph, if the parabolas overlap, then they have it right. So that's what they're looking
So here, let's see on mine or not. I typed in the original function into the y1, and then once I found my greatest common factors out of the box, I typed it in to my y2, and once you graph it, there's actually 2 lines there. It looks like one. When you first graph it, it'll be one color, and then you'll see it overlap it again in a different color. So if they overlap like that, you know that your factored form and it being in standard form up here, you know you got your factors right. Alright, so then we treat it just like we did before. We split them up, set them equal to 0. Just solve for x. So once you solve for x, you should get x equals -2 and x equals -3 halves. Alright, moving on to the back page. Do a couple more with you and then turn you loose. So first steps, set equal to 0, check. Greatest common factor, does 2 go into 9? No, it does not. So we know we're going to have to use the box. What always goes in my top left corner? A does, good. So that's 2x squared. In the bottom right, C, which is 9. What do we do next? Multiply our A and our C. So that's a 2 and a 9. 2 times 9 is 18. So now we've got to find 2 numbers that multiply to be 18 and add to be 9. That's just our B term. So what's some numbers that multiply to be 18? 6 and 3. Yep, and those also 6 plus 3 adds to be 9. So those are going to be our two factors. So we're going to put them in our remaining spots with an X. And it doesn't matter which spot you put them in. You could put 3X in the top right and 6X in the bottom left. As long as you have the right numbers, it doesn't matter for the last two which spot they go in. Alright, let's find our greatest common factors. So going across the top row, 2x squared and 6x. What can we pull out from that? Who doesn't love some awkward silence? Both of these have an X, don't they? So we can pull out 1X. What about 2 and 6? You can pull out a 2. 2 times 3 is 6, but 3, all you're doing here is finding a number that can go into both numbers. 3 can't go into 2. 2 goes into 2, and 2 also goes into 6. So on the bottom row here, we got a 3x and a 9. What can go into both of those? 3. Good. And we don't need an x because our 9 doesn't have an x. Alright, coming down on the left, 1x. Good. Both of them have an x, so we have to pull the x out. Then 6x and 9. Yep, 3. So now we can set what we've got on top and on the side in our parentheses. And again, if you wanted to check your answer to see if what you've got is right before you move on, if you type in the original equation and then what you got, there's the first one. Uh-oh. That's why we always pay attention to what we're typing in. That was a test. You all failed. Miss Brown passed. Alright, now we're good. They're overlapping now. So, we know we're right. Now we can proceed. Break them apart, set them equal to 0, and solve for x. So we'll get x equals -3 and x equals -3/2. Alright, number 10. Set equal to 0, check. 3 does not go into 11, does it? So we're going to have to use the box method. Alright, you all talk me through this. Okay. Six goes on the bottom corner. What next? Alright. So it multiplies to be 18. What does it add to be? 11. What numbers multiply to be 18? Last problem we used 6 and 3. Doesn't look like that's going to work on this one. 9 and 2. They multiply to be 18 and add to be 11. Alright. So which one do I put where?
Don't matter.
Don't matter. So I'm going to put that one there and 2 on the bottom. Alright, somebody tell me what my factors are going to be. 3. Do I need an X with it? Alright, what about on the bottom?
3.
The 2.
Because you can divide them both by 2. You're seeing what you can divide both of them by.
What about going down on the left? 1 and X. And then last on the right, 3. Good. So then we've got, put them in our parentheses, 3x plus 2. Well, and x plus 3. Where do we go from here? Separate them. Set them equal to 0. Then we just got to solve for x. So on this side, after we subtract our 3, you get x equals negative 3. Then on the other side, we'll get negative 2/3. Alright, real quick, I'm actually going to run through number 12 with you because it's a little bit different. And then I'll let y'all do the last 3. I'm going to go through this one kind of quick. So, top left, 2x squared. Bottom right, negative 28. If we multiply our a and our c, we're going to get negative 56. So multiply to be negative 56 and add to be 1. We're going to get 8 times negative 7. And 8 plus negative 7. So we can put in an 8x and a negative 7x. So here's where it's a little bit different. Up to now we've just been dealing with all positive numbers. Now we've got some negatives mixed in there. It changes things just a little bit. So up here, if we're factoring across the top row, those are both positive. So we treat it like normal. We're going to get a 2x out of those. Now on the bottom, we've got a negative 7x and a negative 28. So we're going to be able to pull out a 7. Do you think it's going to be positive or negative? If both of them are negative, we're going to pull out a negative 7. Now, if this 28 was positive, it would still be a negative 7. The way you know if what you pull out is positive or negative is whatever the first number is. So we're going from left to right. We've got a negative 7x, so whatever we pull out is going to be negative. If we were coming down, if this 2x squared was negative, then whatever we pulled out would be negative. But it's not. So on this one, we're just going to have an x. And then over here, we can factor out a 4. So we put that in its factored form. Split them up. Set them equal to 0. We solve for x, we'll get x equals negative 4 on the right. And x equals 7/2 on the other side.